This short video is part of Rouse's series on issues for companies with counterfeit problems. It is an introduction to anti-counterfeiting technologies, or ACTs. These are a vital part of an IP owner's IP protection strategy. Often they are part of a wider product strategy such as tracking, anti-diversion, or batch or SKU identification. Examples include product codes on labels to differentiate SKUs right up to RFID tags. Anti-counterfeiting technologies, or ACTs, help determine the authenticity of a product, whether it is a copy or a counterfeit. Typically, ACTs do three things. They authenticate real products from fakes, they track genuine products, and they act as anti-tampering deterrents to stop interference or copying. Most technologies include some form of marker or specific information which may or may not be visible. Covert or overt markers may be used. Rouse's analysis of the market in 2022 shows three categories of ACT: electronic tags, mechanical, chemical, and physical labels or packs, and unique identifier markings. Electronic ACTs include radio frequency technologies to locate a product remotely through an electronic tag. Active and passive RFID tags are made by various companies and have different costs. Near-field communication, or NFC tags, are stickers with embedded microchips, readable with mobile devices such as smartphones. Costs are usually 10 to 20 US cents per tag, so typically these are used for complex or expensive products. Electronic seals are a hybrid product. They offer RFID or NFC digital tracking as well as product authentication, as they are hard to copy, and they also offer anti-tampering solutions. Pack marking technologies are perhaps the most well-known and widespread. There are too many variants to mention, but they include holograms, watermarks, and product codes. QR codes and other similar codes are very common. These achieve two things. First, authentication, that a product is genuine, and second, tracking, as the product is scanned through the supply process. A variant of these is secure graphics. These are small digital images. Copies degrade, so counterfeiters are unable to reproduce a clean image, making detection simpler. Chemical and physical ACTs. Security holograms are very common for the IT industry. While they can be copied, a hologram reader can determine a real one from a fake one due to embedded data and the high resolution quality. Counterfeiters mostly use cheap, low-quality holograms. Unique inks can be used to mark products for anti-counterfeiting purposes, whether visibly or invisibly. They can have a reaction to certain chemicals or allow a special reading procedure. Watermarking involves images embedded into a label which are technically hard to reproduce, so copycats do not bother or use poor substitutes. Rainbow paint is a way of printing complex patterns into labels and packs. Chemical technology includes DNA coding, chemical traces, glue coding, and other physical markers. These are typically hidden unless they leave a physical imprint. They then enable easy authentication as well as tracking when they are visible. Probably the oldest and most common ACT is unique identifier markings. This basically means unique hidden, usually numerical identifiers such as batch or product numbers. Apparel hang tags incorporate a series of numbers which might identify a factory, production run, SKU, and other data. IP owners may publish these overt markings so their staff, consumers, and law enforcement officials can identify counterfeits. IP owners may train customs officials what to look for or provide manuals so customs can spot counterfeit goods shipments. A second set of covert numbers or markings may help an IP owner track and trace themselves. IP owners might find a series of suspicious lot or batch numbers during trap purchases from an e-commerce platform. From this, they can see that a single counterfeiter has copied and used the same lot or batch number, or identical labelling, not realising the numbers need to be sequential. This enables the IP owner to identify clusters of fake goods and ultimately trace them to sources, for example, factories in China. Often an outsourced tech platform enables the batch numbers to be generated and verified. Outside the physical product area, digital content from music to films to NFTs can have a wide range of DRM systems included in them. Digital rights management or technical protection measures are specifically protected in most copyright laws from tampering or interference. Game makers, film companies, publishers, music labels, software houses and their industry associations work to ensure that DRM or TPM technologies are included in the products and that enforcement action is taken against those cracking or damaging these tools. Specialist software can locate pirated products this way for legal action and sometimes simply shut down the copy product. The future of anti-counterfeiting technologies will involve blockchain. LVMH has partnered with Microsoft and Consensus to develop Aura, a blockchain-based platform to authenticate luxury goods. Shanghai-based VChain also develops blockchain platforms aimed at, among other things, fighting counterfeiting. We hope you enjoyed this video. If you'd like more information, please contact us.